Hey, I'm Jason Brozen, and I am the lead corporate safety and technical trainer with Tyndale. Today, we're going to look at 120.2B as in Bravo. Just to forewarn you, this video might be a little bit longer, a minute or two longer. It's just a lot of detail we're going to try to squeeze in here. Just to recap, in 110.2A in the last video, it told us that our number one option was to de-energize, right? So we've covered that. Let's get to the next text. 110.2B says, when required, energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts shall be put into an electrically safe work condition before an employee performs work if any of the following conditions exist. Number one, the employee is within the limited approach boundary. Or number two, the employee interacts with equipment where conductors or circuit parts are not exposed, but an increased likelihood of injury from an exposure to an arc flash hazard exists. And just to reiterate, this is at any voltage 50 volts and greater. More on that later. But right now I want to focus a bit on the second item, which was interacting. What does interacting mean? Interacting could mean resetting breakers, pushing buttons, resetting motor starters, turning disconnects on and off, etc., etc. I'm sure that you can fill in that blank with several of your tasks that you do daily at your job. Now, does that mean that you need to go put on PPE, you need to de-energize, fill out risk assessments and all that to do these tasks? Well, the answer is exactly maybe. When we start getting into this text, we find some exceptions. The exceptions say normal operation of electrical equipment shall be permitted where a normal operating condition exists. A normal operating condition exists when all of the following conditions are satisfied. Number one, the equipment is properly installed. Now that's going to be per manufacturer, per the 70, per the city codes, per the spec. Generally, that's not an issue. It's typically installed properly. I've seen a lot of equipment not installed properly. That's usually not the rub. Number two, the equipment is properly maintained. That's going to be per the manufacturer, per 70B. I would say that most equipment I've come across is not properly maintained. So right there, you're in trouble. Number three, the equipment is rated for the available fault current. Now, typically the manufacturer, the design, the engineer has designed the equipment for this spec, and that's usually not an issue. Number four, the equipment is used in accordance with instructions included in the listing and labeling and accordance with the manufacturer's instructions. I would say also typically that's not an issue. I'm sure we've all seen equipment that has been misused, but that's not typically a problem. Number five, the equipment doors are closed and secured. Sometimes, right? Number six, all equipment covers are in place and secured, which means all the screws installed, doors closed, everything fastened in place. Now, I don't typically see all the breaker panels having all the screws installed in the covers. That will be another issue for you. Number seven, there is no evidence of impending failure. Now, typically, you won't see that. Sometimes you'll smell that or you'll feel that heat. But number seven, I haven't found to be a large issue typically, although I have run into equipment like that. For the sake of time, I just want to hit on number two, which was about your equipment being properly maintained. This is only verified by having an electrical maintenance program. Oops. How many people have an EMP, an electrical maintenance program? The 70B just became a standard in January of 2024. It spells out that you're going to need an electrical maintenance program. You will need to be very familiar with the 70B, which spells that out, unless you have manufacturer's instructions that do. That's right, I did say a standard. It won't be long before OSHA not only asks you for your electrical safety program, your ESP, but if someone gets injured, they're going to want to also see an EMP, that electrical maintenance program. As an electrician that's spent over 20 years working on equipment, I can tell you with certainty that 99% of the equipment I've seen out there was not properly maintained. Also, before you say equipment is maintained, remember that most organizations, including OSHA, don't care about what you say. They only care about what you document. You have to document this electrical maintenance program. I'm going to leave exception number two alone as it's pretty self-explanatory, but exception number three tells us that energized work shall be permitted where the employer can demonstrate that the task to be performed is infeasible in a de-energized state due to electrical equipment design or operational limitations. This would include, but is not limited to, tasks such as testing, troubleshooting, startup, etc. Infeasible does not mean impractical. Meaning, if you have a panel that has a breaker inside of it that runs your data center, and you need to install a new breaker in that panel, it is impractical, not infeasible, right? You don't want to shut it off because your data center is connected to it, but it's not going to kill somebody. You're required to turn off that panel to install that new breaker per the 70E. This task is not worth the risk of injury or death from shock or arc flash. Exception number 4 tells us that energized work shall be permitted where the employer can demonstrate that de-energizing introduces additional hazards or increased risk. Examples of this might be turning off life support, turning off toxic or flammable gas ventilation, or emergency alarms for that type of situation. Situations that will kill somebody. And just because you say it's infeasible doesn't mean that it is infeasible. You have to provide documentation of this, rationale, reasoning. People have to sign these forms. The bottom line is you can rarely justify energized work per the 70E and OSHA. Exception number 5 pretty much just reiterates that under 50 volts, de-energizing is not necessary as long as you have at least considered the capacity of that circuit in overcurrent protect device to make sure no explosion hazard exists. Forklift batteries. Big battery banks have a lot of energy available to them. There's a fantastic flow chart in the handbook and online at that NFPA link that I told you about earlier that can walk you through that process. It's Exhibit 110.1. I strongly suggest you look at that, and you won't miss any steps if you use that type of information. Next time, we're going to talk about 110.2C, and I'm going to walk you through a bit of establishing and verifying an electrically safe work condition. But we're going to see you next time. I appreciate you tuning in, and stay safe out there.